Today we're going to be talking about net ionic reactions. Now, what is a net ionic reaction? Well, this is a reaction that takes place in aqueous solution. Typically, we're going to be dealing with single displacement or double displacement reactions. The key factor for either way is that at least one of the products is in solution and at least one of the reactants is in solution. So typically what you'll see is a skeleton equation like this. In this case, we have lead nitrate plus ammonium chloride makes lead chloride plus ammonium nitrate. Now, in this situation, our reactants are both in solution. Again, this won't always happen, but at least one of them has to be in solution for it to be a net ionic reaction. We then have one of our products, the lead chloride, is solid, so that's going to be a precipitant. That means something that falls out of solution. So when you get white chunks or yellow chunks or something like that, lead tends to be brightly colored. So I believe this one it's yellow or something like that. And then we've got NH4NO3. So the first step that we have to do is we have to write this as a complete ionic reaction. So that means what we do is we take everything that is in aqueous and we break it down into its ions. Because remember, when we're dissolving something, we're basically pulling it apart. So we're putting it in water, and the water molecules, the positives, are really hungrily attacking the anion, the negative part, and the negative part of the water molecule is really hungrily attacking the cation, which in this case is the lead. So this will break down into Pb, and we know it's a charge of +2 because nitrate has a -1 charge. You'll see that on your polyatomic ion chart, and you see that we have 2 of them. So if we have 2 negatives, that means that this has to have 2 positives in order for it to be overall neutral. So it's Pb +2 Aq plus NO3 minus Aq plus, and then this guy, we know NH4 has a +1 charge, 4 plus, and that's Aq, plus Cl minus Aq. Now, what's important to note here is that when we're coming to the right side, this is a solid. So this came out completely. It's not dissolved. So this is not going to be breaking down into any ions because it's just sitting there as a lump in the bottom of our tube. So we have PbCl2 solid plus NH4 plus Aq plus NO3 minus. So here's the nifty thing. We have this all written out, but we don't need every single thing here because it's not all reacting. For example, our nitrate or our ammonium ion isn't taking part in the reaction. It's just sitting there watching it, basically. So when you look at an ammonium ion over here and you look at an ammonium ion over there, they're going to look exactly the same. Nothing's changed about it. It's very much like a catalyst is, except for the fact that it's actually part of the reaction, whereas a catalyst wouldn't be part of the reaction in the true sense of the word. So what we have to do now is we have to go through and find what's on the left and what's on the right that we can get rid of. So if it's on both sides of the equation, and it's exactly the same on both sides of the equation, we can get rid of it. So NO3, we have one here, and we have one here, so we can get rid of those. Our NH4, we have one here, we have one here, we can get rid of those, okay? So now, what that leaves us with is Pb +2 aqueous plus Cl minus aqueous makes PbCl2 solid. So is this balanced? Well, no. So you need to balance this equation. So we have one lead over here, one lead over here. We have one chlorine here, we have 2 chlorines here. So, and we have to make sure that our charges on both sides are the same. So in this case, our charge over here, since it's a compound, is going to be 0. Our charge over here, as it stands right now, is +2 plus minus 1, so you have an overall positive 1 charge. So we have to correct that. Easiest way to do that? Put a 2 in front of our Cl. So now we have 2 chlorines, which means 2 minus 2s. That balances out our plus 2. And then we have PbCl2 over here with an overall 0 charge. You have 2 chlorines, you have 2 chlorines, you have 1 lead, you have 1 lead. So this is what we call a net ionic equation. That means that we've taken out anything that we're not using and we've gotten rid of it. All that we're left with is the things that are reacting. If we pulled out the rest of everything except the precipitate, we'd still see our ammonium ions and our nitrate ions floating around. So we would see that we would have a solution of ammonium nitrate, but they're not actively taking part in the reaction. So if you need more examples of this, please let me know. Other than that, take a look at the PowerPoint. I have some examples up there for you as well, and take a look at your practice sheets.